So welcome everyone, and this is the last of our sessions. It's got two distinct components and a keynote. So we're going to look at some around this topic of how best to collaborate, and previous comment in the chat of is there duplication? Are we all tripping over each other? So I hope what we managed to do in this session is talk about the degree of collaboration that is already existing and to start highlighting where we can bring that forward even more explicitly as we all move forward towards these common goals. So the first part of this is going to be around partners, and we've picked three organizations, two of which you've heard a great deal about in different places in this agenda for the last 2 days, and one that Eric will talk about that you've not heard very much about. But we picked three organizations that with similar goals, similar objectives, and our three presenters who you've heard from in the last couple of minutes, Ewan Birney from EMBL EBI, and also importantly in this context, the Global Alliance for Genomics and Health. Eric Green from NHGRI, who will actually talk to us about the Global Biodata Coalition, and Rachel Liao, who will follow up on the discussion that Ben Neal started and give us a really deep dive into ICDA and how it can best collaborate with Global Alliance. So welcome to all three speakers. After we'll actually switch around and go to the break after this session, and then we'll start with our keynote, Jeremy, for our at the top of the hour, and the last session of the afternoon, depending where you are, will be industry panelists, and that will be that final stage of how we have to collaborate across so many boundaries, both geographic, sector, and work with industry in order to achieve the goals of IHCC. That's an overview of the session. And with that, Ewan, I will pass over to you and ask you to start our partner presentations with a look at GA4GH.
Great. So I'm Ewan Birney. I'm director of the European Bioinformatics Institute, which is part of EMBL, the European Molecular Biology Laboratory, Europe's only life science intergovernmental organization. But as Peter said, I'm also the chair of the Global Alliance for Genomics and Health. You've already heard, I think earlier today, depending on your time zone, precisely many people who've talked about GA4GH, for example, David Glazier, Thomas Keane, and this hopefully will give you a structure and overview of this organization. So we were launched in 2013, and our goal is to accelerate the progress in genomic science and human health by developing standards and framing policy for responsible genomic and health-related data sharing. It's very important. We're a standards organization. We don't actually deliver implementations of things. We don't run servers. We don't do experiments. And the best analogy for me has been the W3C consortium. So this Zoom call at the moment is chit-chatting between computers using protocols laid out by the W3C consortium. It's using them all the time. You use them every single day, and you probably don't worry too much about how those standards are set up. You assume there's somebody wise and sensible and technical has developed all of those standards and they work together beautifully. So you forget about them, which is quite right. And GA4GH's goal is to have the same role in genomics, that we set up the standards to make things work between different implementations. And by and large, when they work, you will actually, quite rightly, stop thinking about them, except if you're technical, in which case you will love them and want to use them even more. So we aim to enable international data sharing. We are inherently to do here, in contrast to what you'll hear in a moment from Eric Green, we are inherently about human data, and therefore it must be federated. So data which is on human patients and subjects, and much of this data comes with ethical, legal, and sometimes size constraints, and so we must be federated. And we do that by having a process that produces standards, and that involves bringing people together, creating harmonized approaches across that, documenting those, and releasing them to the community. One aspect of GA4GH, which is not technical, is thinking about the ethics and the framing of the ethics of what we're trying to do here. And here, great work by Bartha Noppers now. She's kind of emeritus for GA4GH, activated these two parts of the Declaration of Human Rights, the right to science in particular, and the right to recognition. Now, what's useful about these human rights is that every country in the world has signed up for them. So every government has this on their books. They want to do this. And the second thing is that this framing is a very positive framing. And in some framings, there's quite rightly concerns about privacy and about maybe risks. And those are important concerns to mitigate and reduce. But by framing this whole conversation in the right to science and the right to participate in science, we can have a very, very positive conversation in any context in the world. If you're interested, this is one of the things that GA4GH has released, where you can read about this framework. It's been translated to all sorts of different languages, and it emphasizes our global nature. So just to go into introducing ourselves a little bit, one of these people you know, if you've been on the IAHCC, which is Peter Goodhand, wears many hats in this world and therefore also ensures coordination, and he is our CEO. I'm the chair, the academic chair of the organization, and I'm supported and challenged by two wonderful colleagues in this as vice chairs, Heidi Ream from Harvard and Catherine North from Melbourne in Australia. But we are a big global organization. So we have people who work and help contribute towards our standards across many, many different countries, in many, many different contexts, as shown on the right-hand side, and to deliver this wealth of different standards that runs different bits of genomics. Here is a very brief outline to show what we've been up to since 2013. There was a transition that came in about 2016, 2017, which, partly catalyzed by me being chair, and that was to ground the organization in some very, very concrete technical data sharing problems. That concrete grounding was by bringing in what we call real-world driver projects. So these are projects that span research to healthcare, and they are projects that do implementation. They do stuff. They make stuff happen in their own area. And in that process of making stuff happen, they need standards themselves. And by bringing in these vertical, in this diagram, real-world driver projects, we made the work that we did far more concrete and relevant to many groups. Now, there's an awful lot of different standards we have to put together to make genomic data sharing a reality, federated genomic data sharing a reality. We have somewhat arbitrarily divided them up into these 6 different sections: discovery, large-scale genomics, data use and researcher IDs, cloud, which you heard from David Glazier, genomic knowledge standards, and clinical and phenotypic data capture. There's actually a lot of interplay between them, quite rightly, but this is some way of bringing some structure and not just having one massive conversation, one massive technical conversation. Alongside these technical areas, which we call work streams, we have 2 foundational work streams: the regulatory and ethics work stream that you've seen produce that framework, and other aspects about policy or policy guidance documents. And then an important aspect of data security, which is kind of held out as almost like as a separate system that provides technical peer review, or technical security review rather, on each of the standards that we produce. So just to emphasize these 2 different dimensions, work streams are internal to GA4GH. We asked 2 people from around the world to lead these areas. If you're used to internet standards, they are rather like one of the W3C forums or the IETF forums. And an example is data use and researcher identities. Driver projects are external to GA4GH. They are real-world concrete projects that have deliverables themselves. So here, for example, is the Australian Genomics Health Alliance. That's Catherine and team, and they are delivering medical genomes into the Australian healthcare system. But to do that and to interoperate internationally, they need the standards from GA4GH. This is our rogues gallery of driver projects. You do not have to be a member of these driver projects to contribute and work with GA4GH. Many people contribute without being in any way associated with these projects. So this is not some kind of exclusive list, but it's a way of ensuring that our standards are concretely relevant to the world now, because at least for every standard, at least 2 of these projects want that standard to exist. This is just an indication of where we are kind of as a map, with the slightly darker blue showing our direct engagement. And you can see that we span from healthcare resources, for example, Genomics England or the Swiss Personalized Health Network, SPHN, through to very much research organizations, such as the TopMed aspect or the EpiShare project that looks to bring together epigenomics data. It was been great to see projects from Japan, GEM Japan, and also projects from Africa, the H3 Africa consortium joining, which gives us this much richer global scope. We obviously sit in a standards kind of ecosystem, and we have to work with many standards organizations. So at one level, we build upon many internet standards. So we don't come up with our own concepts of internet technical security. It's more that we use established pieces of internet security in specific ways. But we also have in this area that blends research to healthcare, a really important organization is HL7, and along with the ISO, this very 1970s international standards organizations, ISO, GA4GH, the ISO Technical Committee 215, as it's known, and HL7, we have a kind of holding hands together moment to ensure that the standards that are relevant in that intersection of our area can be used on both sides. But there are many other standards organizations that we interact with. Some of them are from the research side, for example, the Human Genome Reference Consortium, and others are from the more medical side, for example, the SNOMED Consortium. So I could now leap into many of these cases, and I probably need to hurry up, so I can't go through all of them. These are all the standards that we have released. You can go read this documentation, in many cases, download an implementation of this and run one of these things in-house. In many cases, they will work with each other. The HTS-GET server works with the RefGet server and other aspects. We expect many more to come out over the next coming years of these standards. So very quickly, next slide, I'm going to zip through these. These are the sorts of technical standards. This is a way of freeing us from file systems. If you're geeky, you'll know that being tied to a file system architecture is very limiting. This is genomics as a service coming over the wire. And it has one twist that allows it to be very, very scalable. So one step up from an S3 bucket for the aficionados, but that step is very important for HTS-GET. I'm sure that David Glazier mentioned this in his talk about the cloud workstream. This in many ways is quite generic technology, but it's technology that we need from the cloud providers because we want to make portable cloud workflows. And so this is an area here called Workflow Execution Service. And I'm actually hopeful by having people like Google Cloud and Amazon and Microsoft that they will internalize this standard, and it will just be a standard part of their offerings. But we can ensure, therefore, that both the open source clouds, very common in Europe, alongside these big commercial clouds, can have an equal footing in being able to deploy cloud workflows. And this is something that ties the data use ontology, the regulatory and ethics, along with data sets. So this is an electronic way of indicating what a particular data set can be used for. So for example, the data set can only be used by non-commercial organizations and perhaps only for this particular disease question. That unfortunately is a slightly old-fashioned, but nevertheless quite common way of structuring some ethics. And so we have quite a few data sets with that kind of criteria on them. And we need to have that in a computable form so that people can ask questions. Can I actually see this data without having to go through some email or, God help us, PDF fax moment to ask that question? This is, do get involved. You can join a work stream. You absolutely do not have to be a driver project. And by design, we have set up the relationship between the technical side of the IHCC to be part of the appropriate GEO4GH work streams. So that interconnection has been designed in from the start. So that's me done.
Ewan, thank you very much. So our next speaker is Eric Green, probably known to everybody on the call as director of the NHGRI, and both at a personal level and organizational level, one of the strongest supporters and passionate drivers of collaboration in international genomics. In this case, Eric's going to talk to us about something very different. And so, Eric, over to you.
Well, thank you, Peter. Thank you for your kind words. Happy to be here and really enjoying this virtual meeting. I'm going to tell you about something that's much less mature and developed than what you just heard from you. And it also has sort of a different group that's going to be involved in this most directly, and that the group are funders. This is basically a new coalition that is forming of international funders to try to address some important problems related to data resources. The origins of this actually date back to a paper that three of us who were leaders at NIH getting involved in tackling sort of the big data problems and the evolving ecosystem issues put together when NIH was trying to get its house in order about 5 years ago. And so we put our thoughts down on paper. And on the next slide, a paragraph near the end of that brief perspective on the next slide sort of emphasized that we really needed funders to better coordinate things. And in particular, as you can see in the highlighted section, we pointed out how changes to funding practices need to extend across both agency and, importantly, international borders. Data generation and maintenance are typically funded nationally, but the data are used internationally. And so we really talked about the need for more equitable funding models, but most important, just start by collaborating and coordinating how funders are dealing with these data resources. In a very simple sense, what we were realizing was that the Biomedica data resources are absolutely vital to what we do, but ironically, they're incredibly vulnerable. And we were encountering this even at the NIH level, and it was even more amplified at the international level. So on the next slide are a series of bullets that are basically known to all of you, is that biomedical data resources are vital. We depend on this ecosystem of publicly accessible data. It's a very distributed infrastructure that facilitates the sharing of research across many different sectors. But there's thousands of these things. There's like well thought to be 3,000 biomedical data resources, and about 100 new ones crop up every year. Many of these are useful to very small groups of people, but a small subset of these are sort of could be considered core. Maybe about 100 of them are estimated that are used by millions of people each year and are associated with funding that maybe approaches about $500 million, although that represents a small fraction of the total biomedical research expenditure, probably well under 1%. Now, these data resources, and particularly these core data resources that so many of us are familiar with on the next slide, all exist, and actually the resources themselves interact extensively. And here are some representations of the kind of way that data is exchanged and interacting across various data resources that are familiar to all of you. So on the one hand, all of this makes total sense, and we rely on these, and they're healthy, and in some ways on their outside appearance, and they're highly interactive, and we use them millions of times every day. But on the next slide, the reality of it is that they're actually quite vulnerable. Data growth is growing exponentially. We're being stressed, appropriately so, by many new open access policies in different parts of the world that are increasing the demand on these resources. New technologies, genomics most obvious, but other technologies are requiring new data resources to be created. And yet, and I can tell you this firsthand at NIH, funding of these data resources is fragmentary, it's fragile, it's really quite haphazard. Even at NIH, it's not even very well coordinated. And yet, as you can see on the next bullet, there's very poor, actually practically no, with minor exceptions, international coordination among funders. And this was very clear, leading to duplication, waste, and a lack of a sustainability plan going forward. So while we're all dependent on these resources, it's amazing that the funders were not better organized to think about their long-term future and their needs. And this is yielding problems. Possible funding curtailment that could happen at a very local level, risk the loss of important resources. And meanwhile, because the system was being stressed, there were growing threats of data resources retreating behind firewalls, which would be terrible, making them inaccessible, in particular to low resource setting scientists. The bottom line is a number of us recognized that there were dark clouds on the horizon, and we needed to do something to start to think more practically about the future. One of the people who actually read that perspective piece that we published in Nature in 2015 is Warwick Anderson, who is the director of the Human Frontier Science Program. And Warwick was so enamored by this important set of issues that were before us that he, working with me and several others, convened a group to get together at HFSP headquarters in 2016 to start to tackle the global dimensions of this big data problem that many funding agencies were individually starting to address over the past 10 years. And we brought together funders and also stakeholders, resource directors, and so forth. Two things came out of it that we shared in publication form, one a very short correspondence in Nature on the left, and a longer piece which you can access, which is a preprint in bioRxiv, that really described the current situation and frankly pointed out that it was really unsustainable. There were inequities, there were vulnerabilities, and most important, relevant to this coalition, there was poor coordination. We needed something and some group to step forward to better coordinate the funders taking care of these resources. So on the next slide is we decided to establish something called the Global Biodata Coalition, or GBC. And there's a small steering group that I'm a member, and there's a number of other people involved that have worked for about 4 years developing plans for creating this coalition. The coalition of funders would coordinate and enhance support for not all data resources, just the most important ones, at least initially, with the aim of trying to ensure the sustainability of these core data resources and, importantly, the continued free access. And as I said, this coalition is just getting its legs under it, and it aims to launch later this year. If you were going to put in bullet form what we regard to be the mission, we want to provide the first ever meaningful coordination among international funders of biomedical data resources that aim to ensure the sustainability of these data resources and the continued free access of the data through more strategic and more global stewardship. Hopefully, we will expand the number of international funders involved in sustaining biomedical data resources by having a coordinating group at an international level. And in doing so, we hope to enhance data resource-related expertise, not just in a limited number of countries, but in a larger set of countries. Now, let me emphasize on the next slide, we are not tackling the entire universe of data resources, the 3,000, and that would be biting off too much initially. We are especially initially just focusing on what we are going to identify as the global core data resources, which we estimate to be maybe about 100 that are the most heavily used, the most incredibly important ones for the greater ecosystem of biomedical and life sciences research. How will we do that? Well, the good news is we don't need to reinvent the wheel, because Europe is way ahead of us for a number of years, putting together a group called Elixir, which is developed through, and you can see in a couple of publications, sort of a strategic approach for deciding what are the most important resources for the European funders to support. And they have developed metrics and an approach that I think is quite robust. And as much as possible, we will simply adapt the kind of strategies and routines they have put together, but now take it beyond Europe and look at it on a more global stage. If you ask me what's the current status of this new coalition, first thing I'd point out is that we're not sort of flying on our own. We are actually tightly affiliated and checking in regularly with the heads of international biomedical research funders, or the HEROES group. This is a group that currently chaired by Jeremy Farrar, prior to that by Francis Collins, a group of funders that get together regularly and talk about a number of things about the global situations in biomedical research. And we are tightly keeping in touch with them to help both because they want us to be doing this and because we want to have their support in trying to get this coalition off the ground. We are just now finalizing governance and budgetary documents to make GBC a reality. This involves going funder by funder to engage, make sure they understand what we're doing, and getting them to agree to join the coalition. It also involves ongoing outreach to community stakeholders that we'll eventually be dealing with extensively, the heads of these data resources. Initially, the HFSP is hosting us and a small secretariat that we're establishing to make things happen. And then we're doing a number of things once we got off the ground, including developing this process for selecting the initial set of global core data resources. And that's going to first involve just getting an inventory of what's really out there, because no such inventory actually exists at any sort of accurate level. Just recently, we actually got a website up. So a lot of the things I've just told you, you could read more about by going to this website. I would encourage you to do so. And so in closing, I put into words what success might look like, say 10 years from now, either at a minimal level or at a realistic level, or maybe with remarkable success. I'm not going to go through these. It's just sort of a series of increasingly optimistic views of what we might gain by having better coordination of funders supporting data resources. I would just draw your attention to the very last line on this slide, because we do believe this is very important, that the GBC fits into this grouping with things like we just heard from Ewan, or you're about to hear from next from Rachel, and all being sponsored by this organization of IHCC for this gathering, this virtual meeting, but other organizations as well. You can see how they interconnect to create a dynamic global ecosystem for biomedical research data, and this is very important. And then if you don't want to read words, I'll just leave you with what I think is just a core visual for why I think this coalition is really important and why I've put a lot of energy into it. I make the analogy to sort of air traffic controllers. I think in many ways, certainly when I became director of NHGRI and I started learning about the data resources that we were supporting as one institute at NIH, let alone other ones being supported by other NIH institutes, not to mention by global funders, I feel like this was the situation. We were cleared to do whatever. And what the Global Biodata Coalition hopes to do on the next slide is just simply make this a more rationally better coordinated and better synchronized set of funding groups that are taking care of the broader ecosystem of data resources. So last slide, which is just lifted from the website, talks about who's funding the basic secretariat and who's providing in-kind support to make this coalition start up. And I will stop there and look forward to any questions that are at the end. Thank you very much.
Eric, many thanks. And I'm sure GBC was a new acronym for many people, but I'm very pleased to see the way it aligns with the other ones that you mentioned. And on the third of those, great pleasure to introduce Rachel Liao from the Broad Institute, but in this context, most importantly, the Executive Director of ICDA, and somebody I've had the pleasure of working with for the last 5 years on multiple international initiatives. So Rachel, over to you.
Great. Thanks so much, Peter. I'm really excited to be presenting a little bit deeper dive of ICDA, the International Common Disease Alliance, which for those who were on the conference earlier in the day, you got to hear a little bit of an overview from Ben Neal. During this partners session, I'm really excited to do a little bit deeper of a dive into just how ICDA and IHCC members might be able to partner, some of the opportunities for collaboration, and where I see real complementarity in our efforts. As Peter mentioned, I work at the Broad Institute as scientific advisor to the director, and as part of that role, I am executive director of the ICDA, which I will describe to you and some of the work that we've been doing. So you saw this slide earlier. The central dogma of ICDA is what we call the M2M2M challenge, that stands for Maps to Mechanisms to Medicine challenge, really a fundamentally scientific question and a genetic-centric focus on common disease and common traits. Really, the core of this challenge is a goal to release the bottlenecks and accelerate progress in moving from genetic maps to understanding the functional impact of variants identified in genetic maps at the molecular and cellular levels, ultimately to enable us to understand biological pathways implicated in disease physiology, ultimately with the goal of making meaningful progress toward new and better treatments for common disease. So with that as our central scientific dogma and question, our ICDA is really a forum of really quite diverse scientific and policy and funding stakeholders who are invested in seeing this scientific question move forward and making this acceleration possible. Now, I think many of you are aware that ICDA launched publicly in September 2019, which, despite how it feels, was less than 8 months ago. We had several planning meetings leading up to that point that you can see listed here. And this public launch, which we were able to host right outside of DC, Washington, DC, was primarily in order to present an initial white paper, what we called version 0.1, and present that to the global community with what we believe the impetus is for launching ICDA. I think that we were excited and happy with the enthusiasm that was met with. And so following that meeting, we began thinking concretely about what early projects might help drive forward the goals that we laid out in that white paper. Ultimately, we identified several ICDA recommendations. What we ended up being able to release in early February of this year, calling them version 0.9, which are intended to be exemplar projects for the overall framework for how to solve this Maps to Mechanisms to Medicine challenge for any common disease. Now, I'll caveat that statement by saying that these recommendations are not an exhaustive list of all possible directions or projects that could be undertaken in biology of common diseases. Rather, they're an initial set of focused on translating genetic discoveries into mechanistic insight to further therapeutic development for any common disease. So that's to say, they're not exhaustive. They're not covering every possible question that could be asked, nor are they complete. These are going to be living and will be evolving. There will be future releases, and there will be opportunities to hear from more and more members of the community. And I'm really proud of the amount of community engagement that we've been able to see in the process of developing these recommendations already. I should also mention we were intending to have an in-person meeting in Copenhagen last month, which of course was not able to take place. At that point, we had hoped to release version 1.0 of these recommendations. Given the global circumstances, that updated version is still in the works, but hopefully will be being released in the next couple of weeks. For right now, you can go to our website, icda.bio, and on the homepage, you can download version 0.9 of these recommendations. I am going to go through them now in a little bit of detail, assuming that you won't be able to skim the 38-page document that's there, which is honestly going to be probably closer to 50 pages for version 1.0 because of the enthusiasm and the amount of great feedback that we've received. So the initial recommendations include 23 proposed efforts, which include foundational genetic and genomic resources, critical computational tools, activities to propel therapeutic development, important areas for new innovative research and training, and strategies to promote global equity. We visualize it, as you can see on this in this graphic on the right that I think Ben also presented earlier. And then I will, so now I'll be transitioning to go through these in just a little bit of detail and hopefully highlighting where members of IHCC and IHCC as an organization might be able to partner with and collaborate with ICDA as we pursue this scientific vision of translation from maps to mechanisms to medicine for common diseases and traits. So the first direction that we have outlined is really a cross-cutting recommendation to launch flagship disease projects, which are intended to serve as a test bed and span the entire M2M2M challenge. All the subsequent recommendations can really be components of these flagship disease projects. The goal here is not to exclude common diseases or traits, but really to highlight the different progress that's been made in many common disease communities up until now, to see how we can build on and accelerate their ability to translate the variants that they've discovered associated with common diseases into mechanisms that may ultimately lead toward better therapeutic development and medical use of these data, these genetic data. We have suggested that flagship diseases might be launched for at least 10 important diseases, but again, at least is the real key there. there are a variety of selection criteria that you could imagine to really suggest which diseases we might focus on first. And those discussions are active and ongoing in our community right now. We hope that the diseases we pick that are initially started with work will be variable in the state in which they fall along this continuum from MAPS to mechanisms to medicine, in order to play this testbed role for the M2M2M challenge components that I'll describe now. So direction number 2 is going to be very familiar to this community, thinking about the MAPS component of the M2M2M challenge. We have goals to, in the context of biobanks and cohorts, to promote diversity, utility, and analysis that can be performed. Obviously, this is a point of great overlap and collaboration potential with IHCC. We also hope to be able to develop, as a community, develop genetic resources that enable us to catalog and curate genetic variation that's identified across different populations, different disease states, as well as some comprehensive collection of standardized summary statistics for all of the association studies that have been done that would be of most value to move many of these translational efforts forward. Direction 3 is the mechanisms component. These projects are targeted at identifying the molecular and cellular functional consequences of genetic variants, really mapping many of the regulatory elements in cis and in trans to identify activated cellular programs, the genes of the targeted genes of variants of interest, the targeted cell types, all of the different cellular and molecular consequences that may be an effect of variants that are implicated in common diseases. And we would like to call out a specific systematic characterization for protein coding variants, given their unique outsized role often in the development of common diseases in many contexts. Direction 4 is the medicine component, which includes projects that will focus on developing functional assays to unravel disease-related processes, as well as identifying biomarkers that will support clinical translation, as well as using genetic information and developing best practices for the use of genetics in medicine, such as in selection for clinical trials, as in using polygenic risk scores in clinical care. We have a very active pharma council in particular who have been really leading our scientific strategy in this area, thinking about how we might improve our ability to use genetics as we translate into concrete and actionable medical space. I think there are many of the cohorts in IHCC that are collecting these types of health data that could really be connected back with genetic information and move some of these efforts forward. So I combined directions 5 and 6 because these are so complementary to much of the work that's already been described here. Data and policy are obviously of high importance to this community and to all users of big biomedical data. And I don't need to convince anyone here that the diverse data that are generated in diverse areas of the world will require both infrastructural resources as well as policies and ethical regulations in order to be used effectively and shared effectively. Certainly, Ewan just described GA4GH's extensive work in this space, as well as work that's been done with the IHCC. And I'm very excited that we've already been able to collaborate with members of IHCC in some of these contexts, especially with Thomas and Philip and David Glazer in the data group in IHCC, as well as collaborating extensively with folks from GA4GH as we think about some of our early policy expectations. And my hope is really that we will be able to continue driving these collaborations forward as we all continue to develop these organizations. And then the final direction, which I'll just briefly mention, is what we call innovation, which is just calling out a lot of the excellent work that's already being done at the funding level to support and promote the development of new methods, new technologies, new training programs in order to recognize that we can't stop where we are, that the development of new technologies and new scientific directions is really going to be crucial to ultimately solve the M2M2M challenge. I realize the secondary text is a little unclear. ICDA is not primarily driven by funding bodies, but we envision this direction of innovation primarily to be driven by funding bodies whereas ICDA is committed to being supportive of that vision, which is very much ongoing at the funding level in order to promote innovation that will accelerate our progress, and especially through promoting equitable connections and collaborations among researchers around the world. So I hope that I have laid out a little bit the way that we see the power of human cohorts to address the M2M2M challenge. Obviously, there is extensive opportunity for discovery in any disease or trait in the cohorts that have been assembled and are being assembled. There's unique population history that can really influence our ability to understand the specific nature of variants implicated in common diseases. There's also tremendous opportunity to use genetic association studies to discover and to infer and to develop experiments identifying biological functions of disease genes and pathways, to study common processes among phenotypes, to identify the cell types that are implicated in diseases and the cellular pathways that are implicated in diseases that can ultimately be used to identify patients at higher disease risk and then truly inform their medical care, either through the development of new therapeutics or the identification of individuals at higher risk and the ability to make interventions into their health at earlier stages. We are really excited to see how all of this may come together, because it's obviously still very early days, but I'm personally very excited about the opportunities to collaborate across these complementary efforts. And we've been following with great interest IHCC's efforts to organize and catalog and increase the utility of the world's largest population cohorts as we think about how to move forward in this space. I will just return to this vision for the M2M2M challenge, which is that as a community, not just as ICDA, but as a global community, which is certainly, I think, more and more on all of our minds in the current global circumstances. As a global community, we can work together to eliminate the bottlenecks and accelerate progress in moving from maps to mechanisms to medicine to benefit folks around the world as we think about improving health in common disease space. And I will just make one brief pitch, as Ben already mentioned, that one important common trait that we are thinking about is viral host genetic susceptibility and severity of outcomes for folks who have been infected with the coronavirus and had the disease COVID-19. I do encourage any biobank or cohort that has data that might be interested to collaborate in meta-analyses of some of the genetic factors affecting the host genetics of COVID-19 infection, to reach out to ICDA-office at icda.bio or to visit the website covid19hg.org to learn more about this really exciting effort that has moved forward very quickly. As Ben said, is already released initial summary data and continues to aggregate more and more data contributors and to do more analyses in this host genetics of COVID-19 severity and susceptibility. We would love to collaborate with you if you are interested to do so. And with that, I will end. Thank you so much for your time. I encourage you to find ICDA online and certainly to reach out to me if you have any interest to collaborate on any of these works that I've described, or you have any other questions. Thank you so much.
Rachel, many thanks. I've been monitoring the chat questions, and almost everybody's been using all panelists and attendees, so everybody's seen the questions. And I think almost all the questions have been answered by the person most relevant to ask them. So we've had some great conversations about listing the GBC core products, about using architecture from the Atlas. And I think the only one that I didn't see go to everybody, Rachel, this was probably just a suggestion that when it comes to prioritizing areas of disease focus, then looking at the global burden of disease maybe in selecting those top 10. So I don't know if you wanted to comment on that.
Yes, absolutely. I think that global burden is a key criteria for selection of diseases.
Okay, and then I think Eric made the point about the importance of HERO, and it is a critically important group that does sit high enough in the global funding scheme that it sees the value of these different resources and puts enormous encouragement, shall we say, on all of the things you've just seen to work together, to not duplicate, to align and find our place in order to work together. So I think with that, we'll close this session. We ran a little bit over time, but there was some great chat in there, and I think we've answered most of it.